students. So now we are here to have some solutions of the questions that comes from the composite one. Remember, we discussed about composite functions. We wrote its definitions. We tried to explain what is the meaning of composite. Now let's have some solutions and let's represent some answers of the questions of the composite functions. So first of all, example number 1, and most importantly, don't just look the classes. Don't just look the classes. Try to follow the class in your copy too. Now number 1 is here. If f is the function that defines the relation from -24, -18, 0, 0, 1, 4, 2, 6, and g is the function that defines the relation from 0 to -2, 4, 0, 6, 1, 8, -2. Find the set of order pair of the pairs. Now this is the main important. If you remember what I told you, GOF and FOG are not same. Remember, GOF, F is the first, G is the follower, second function. FOG, G is the first, F is the follower, it is the second function. Now in our question, which one is the first function and which one is second function? Can you tell? Exactly. F is the first function, G is the second function. So first means let's now write the first function first. Remember. Now let's work on the first function. Okay. So now look here. The solution goes like this. Solution. Now I am representing in arrow diagram, mapping diagram first of all. The first function is here. So let's work on the first function. That is, this is the pre-image image. Now the pre-image. Look here. -2, 4. -2, 4. Next, -1, 8. -1, 8. It is quite small, please. 0, 0, 0, 0. Second, 1, 4. Again, 2, 6. This is the function F. Function F. Okay. Function F. And the second function G. F is followed by G. F is first, G is second. G. 0 becomes -2. Find 0 here. Now find 0 here. Find 0. 0. 0 becomes -2. Remember, 4 processed, output is 0. 4. 4 is 0. Now 6, 1. 6, 1. Now 8 -2. 8 -2. Same. There are 2. Okay. So you can write same, or you can give another -2 here. It doesn't make any difference. So this one. 4. There are 2. Okay. And 4 becomes 0. 4 becomes this one also 1 here. 4 becomes 0. There are 2, 4 here. So let's write it. Okay. Find the set of order pairs of GOF. GOF from F to G. Remember, 2 becomes now, -2 becomes finally 0. 1 becomes finally -2. 0 becomes finally -2. 1 becomes finally 0. And 2 becomes finally 1. This is how we write the order pair, that is GOF. GOF. So this is the first solution from the composite functions in the sense of mapping diagram. Remember. Now we will go in the algebraic relations also. So this is the example first. Now let's go to example second. Now, example 2. Example 2, how to find the composite. So, second example here. If f x equals to x minus 3 and gx equals to x plus 5, find f o g x and g o f x. So they both are composite between f and g, but it depends upon the formation. Which one is first, which one is second. So dear students, please look carefully. Now we are finding the composite in terms of algebraic expression. Okay, so let's find the first composite f o g x. I number f o g x. So can you tell me which one is first function here? G. Definitely g should be processed first, and that is followed on the f. So now let's write it here. F for which gx is the input. This is the meaning. Now the gx is here, x plus 5. X plus 5. So x plus 5 is now input for function f. So x minus 3. Now let's put x plus 5 here. So what you will be getting as the result? X plus 5 minus 3. That is x plus 2. So this is the composite of f o g x, where gx is the first function. Now again, second, g o f x. G o f x. Same is the case here. F x will be the input of function g in this case. So now the f x is, now you can see there, x minus 3. Now the x minus 3 is the input for function g. Don't forget, x minus 3 is the input for function g. So look here, if you give one input, here will be 1. If you give 2 here, here will be 2. Now that we have the input here is x minus 3. X minus 3. So remember, here will be x minus 3. So now x minus 3 plus 5, this is x plus 2. So you got the same, but in every case it will not be same. But it can be same in some cases. So this is how we get the composite function. Remember, composite in terms of the algebraic one. So now I am presenting you the last example on the composite, and please turn over your book, your practice book, and try solving this, try solving the answers if any confusions come in. Now I am going for the last example on the composite. So we have, for the example, now, okay, function. So this is another example from the composite function section. So we have some here mixed problem. We have mixed of inverse also. So according to question, what is given here is, if fx equals to 3x minus 7, gx equals to x plus 2 by 5, and also g inverse O fx, that is f followed by g inverse equals to fx, find the value of x. Now let's come to the important one. If you understand this, I hope it will going to be helping. It will going to help you in the examinations, in your exercise solving very much. So first of all, let's again read the question. Fx equals to 3x. There is first function fx. Sorry, one function. Second function gx. And there is one another relation given. That is fx followed by g inverse will be fx. So what I am explaining here is fx followed by g inverse. Do we have g inverse here? No, we have g. So what your mind says now? We have to find g inverse first of all. Remember, our first target is to find the g inverse. Now we have to go back to our previous classes. How do we learn about the inverse finding? Gx, xy interchanging role, finding the y, that will be the gx. So now let's talk about what we need. We need g inverse. So solution, gx equals to x plus 2 by 5. So gx itself is a range. So range is written as I said you y. That is, or in book you can find it gx written as y like, and gx equals to y lake. Therefore we can write y equals to x plus 2 by 5. Now what we did for the inverse, please don't forget, interchanging the role, place, whatever you want to write, please write the place of x and y. Now what we get by interchanging? Therefore x equals to y plus 2 by 5 or 5x by mathematical rule. You know better than me. Now again, 5x minus 2 equals to y. This is the g inverse. It's equal to 5x minus 2. I hope you are understanding it. You are copying it also. So this is the g inverse. So now I will write my result here. So I got g inverse x equals to 5x minus 2. I got this because I need to use it later. I don't have much place. I am going to rob it. But for you, please copy. And now next, that is, the next is fx followed by g inverse will be fx. So by this relation we are getting the value of x here. So now my solution is here. Now my solution will be continue from here. So for that I have to rub it. Now what we have to use here is again g inverse O fx. That is, fx will be the input for g inverse. Now fx, g inverse having the input 3x minus 7. Now let's make the process of 3x minus 7 on the function fx minus 2. Don't forget what we got there. G inverse x. This is what we have to do here. Now the input for g inverse x, x minus 2. So it means 5 3s are 15x, 35 minus 2, 15x minus 37. Okay, we got exactly 60-70% of solution. Now we have to make it equal according to equation. So according to equation, we have one important relation given. G inverse O fx equals to fx. That means this whole part, what we got here, 15x minus 37 equals to fx, means you can see there fx as value 3x minus 7. Now you know how to make it like terms on the different side. So 15x now minus 3x, because they are like terms, minus 7 plus 37, or 15 minus 3, 12, minus 7 plus 37 is 30. Therefore x is equal to 30 by 12. So this is the answer according to the questions. If there is some mistakes, calculation mistake there. So this is the one important relation questions that you should know in the composite function. So this also concludes inverse composite functions, everything. So for the further informations, I will join you on the next classes. Till now, thank you, and don't forget to subscribe Great TV. Thank you.